Okay, Houston, we've had a problem here.
This is Houston. Say again, please.
Houston, we've had a problem.
Now I want to talk about earthquakes that are kind of where and close to where we live. Now we live in Colorado. Some of you may be watching this who don't live in Colorado, but where are earthquakes around Colorado, and actually where are the active regions in the United States? So we're going to talk kind of about where in fact are the volcanoes in our world. Okay, so where are these volcanoes? All right, here we go. Here's a map of Colorado, and if you look, it's hard to see the maps. I wish they had chosen a different color, but the most earthquakes, pardon me, did I say volcanoes? Most of the earthquakes in Colorado are down here near Alamosa. If you look here, each of these little dots represent. You got a little one here. We've got a few up here. Colorado Springs is right there. And notice right here, those of us who, this is approximately where we live in Woodland Park. So we do get some small earthquakes in Woodland Park. We also can see the depth based upon the color scheme. Most of these are not that deep or whatever. Grand Junction has a good cluster, and you can kind of see these clusters of volcanoes. I keep saying volcanoes. These clusters of earthquakes that occur in Colorado. So there's fair regions, but obviously the most active region is down there. All right. Today we want to cover some words that you're going to learn the definitions of. They are transform fault, subduction zone, risk and hazard. Risk and hazard? I bet you know what those mean already. All right, let's talk about what a transform fault is. So here's a picture of a transform fault. Okay, now basically you have two plates. Plate number one is moving in this direction, as indicated by the arrow there, and then the other is moving. So that's kind of when they slide past each other. Here's kind of a cool picture right here that kind of illustrates. Here's a farmer's field, and if you notice here, we've had a problem, right? Is that this field right here has moved this way and this way. Farmers don't typically plant their rows. They do it in a straight line. They don't do this, do they? Their tractors don't do this. So there was an earthquake, and that caused the ground to move, and since this is then thus called a transform fault. Hey, let's visit with my friend Bill, and Bill's going to explain a little bit about transform fault.
See this? Solid rock. But just a few years ago, it was a liquid. This is lava, and it came flowing down this hillside when the small plates that make this the island of Hawaii slid like that, slid like this. Made a lot of small earthquakes, too. We're still getting a lot of small earthquakes around here today.
Here in Hawaii at the Hawaiian Volcano Observatory. This is a station of the U.S. Geological Survey, and we basically studied the volcanoes and the earthquakes that go along with them. These are three of the seismic drums where we record a ground shaking that is a continuous vibration caused by magma moving in the eruptive dam. Here, the fault plane is horizontal, and one plate slides over another plate.
Like this.
A normal earthquake is stored up energy that gets released as the ground or the rocks break. The faults are generally vertical, and the movement is like this. Here's Kilauea. We're standing right up here now, and the eruption that we were looking at the vibrations of the ground from is out here. And the part of the volcano that is moving towards the ocean is this entire piece that is sliding out. It's being pushed outward by the magma system. The magma is coming up underneath and then pushes this flank out.
Well,
this is science.
Let's take a look at another picture of transform faults. We've seen this picture before. This, of course, is the Mid-Atlantic Ridge. Here is South America, North America, and Africa over here. But essentially what we've got is we've got these transform faults, and they're going across the mid-ocean ridge. So you kind of see this is going this way. That's not a very good color. Let's change. How about maybe red? This is going that way, and then this is going this way. So each of these lines, this is a transform fault. Even though the main thing is the diverging plate boundary here, you've also got lots of transform faults through here. Here's a good picture right here with a lava lake right here. But you can see this. Oh, now I need to change colors. Probably to white. I go to white. As you can see, this stops. So essentially one has moved this way and one has moved that way. So you can even get transform faults as they're in divergent plate boundary. This is kind of the classic way to see what's actually happening up here. All right, now let's talk about a subduction zone. We've already kind of talked about this. I'm not sure we need to spend too much time, but this is where the subduction zone occurs. Remember, subducting means going underneath, and so as this plate goes underneath and dives under this plate, this is a continental plate right here, and this is an oceanic plate or oceanic lithosphere. All right, we use the word plate sometimes. This creates this melting, and yeah, I think we've already talked about this in other podcasts, so I think we will move on. Now let's talk about risk versus hazard. Well, risk versus hazard. So basically this map is kind of a key map, and you'll have this in your book or one similar to it. And this basically, if you've got a white or a green, you have a low hazard for earthquakes. And so if you kind of look where we are in Colorado, we're not quite here, but we're kind of here maybe white and green. That's where we're at in Colorado. But some places in the world, you have a very high risk for earthquakes. Very high risk. In fact, if you look right here, that's where we had the Haitian earthquake just a few days, about a week ago, I guess now, in January of 2010. And notice kind of along the ring of fire, these are where the plate boundaries are. And then if we jump over here to Europe and Asia, we can see lots of activity right through Turkey, Pakistan, etc., Japan, Jakarta. If you recall, there was a tsunami a number of years ago that rocked this area and sent a tsunami that was very devastating. So risk versus hazard. So you can kind of see what parts of the world are the most dangerous to live in from an earthquake perspective. All right, we now want to talk about a number of things. The San Andreas fault system. Talk about this. We've already, I think, alluded to this, but most earthquakes occur along plate boundaries, the depth of earthquakes, and the U.S. risk for large earthquakes. All right, let's talk about the San Andreas fault system. So the San Andreas fault, as we look at the San Andreas fault, is a transform fault, meaning that the two plates are moving side by side in opposite directions, and this is what's causing the San Andreas fault. It happens to go right through land and right through San Francisco, California, and just to the north and east of Los Angeles, and you can kind of see this. And it's actually an interesting transform fault. Remember we said about the mid-ocean ridges that they can have transform faults along the mid-ocean ridge, and that's essentially what you've got going on here. This is an extension of the mid-ocean ridge through here, and we can see several of them, these transform faults along mid-ocean ridges that happens to also go through California. And interesting thing, a lot of people think that California is going to break off and become a part of the, become an island, and that's not exactly true. I mean, this whole section, like from here to here, is moving this way, and at some point will be out here in the ocean, but it's just a very small portion of it. It's not the whole state of California. All right, let's now talk about global seismicity. This is the epicenters of all of the volcanoes, all of the earthquakes. They follow the same pattern as volcanoes, by the way, all of the earthquakes in the world, so we can kind of see this. And in fact, I've got a cool little video clip that we will show them sort of forming. Remember, most earthquakes are small earthquakes. So yeah, let's watch this cool video clip of the different earthquakes. Now, one thing we really haven't talked too much about is about earthquake depth. Okay, now as it turns out, there are sort of three levels of earthquakes. There's deep, intermediate, and shallow. So if we look at this picture right here, particularly notice that a subduction zone, because remember, say that the earthquakes occur at plate boundaries. Well, the blue color right here represents shallow earthquakes, the yellow would be intermediate, and the red are very deep earthquakes. Earthquakes don't always happen near the surface. The epicenter, if you recall, is just above that particular location, right, above the spot where the earthquake occurs. Now, I want you to transfer this graph over to this graph, because if you look now here in Japan, we can see the blue, which of course is the shallow earthquakes, and the yellow are the intermediate. You see those right here, and then the reds are the deeps. Now, if you can realize that the deep ones tend to happen here, which is not really technically on the plate boundary. The plate boundary is where you have the blue earthquakes, if you will, or the shallow earthquakes, and then they're all happening along the same area, but these maps right here, of course, just epicenters as opposed to how deep they are. So we can figure the depth of the earthquake by kind of where it occurs, if that kind of makes sense. And then also this map over here, if we look at the big worldwide map, most earthquakes are of the yellow variety, which is the intermediate, and then we've got some orange ones, which are the shallow. Actually, it doesn't say the depth. So the yellow, pardon me, are the shallow. I said that backwards. The orange. This is a different scale. The orange are the medium, and then there's some in the red. And it follows that pattern. If you look here along, say, South America, it follows that same pattern that we just talked about. Okay, here's a good one also. If we look at the earthquake depth in Alaska, again we have the depth very shallow here down to very deep. Deep is -800. I'm not sure if that's in kilometers. It doesn't matter. I doubt it's probably, I don't know what the units are, but you can kind of see they follow that pattern where the lighter colors are here and then we get the blue. It's the same concept here is we have a plate boundary going right through here, but this plate is going this way and this plate is going this way, causing the depth of the earthquakes in Alaska. Now, let's talk about the hazards in the United States. Where is it dangerous to live in the United States? Okay, the highest hazard, 32 plus, looks like we got some California issues here. It looks like California and right in the middle of the America, yeah, there's a big problem right here. We're going to talk about that in a minute. And then, of course, Alaska over here. That's where the biggest danger. We live in Colorado. We're right here, so it's just kind of a moderate risk. In a white, if you're right here, nothing to deal with. Texas, you're in good shape. Montana, nothing wrong. Wisconsin, Michigan, etc. over here, not a big deal. So this is the hazard map for the United States of America. All right, here we go. Now, what about Colorado? Where's the worst issue? So we live in Colorado, of course, and so where do we have problems here? Colorado Springs, we're going to just be a light blue, so not very big deal. Notice we have none that are up here in the very dangerous area of volcanoes. The worst area is kind of near Grand Junction and then down near Alamosa. We saw kind of a clip of where those are, and that's where your big issues are in Colorado. All right, let's talk about the major earthquakes in the United States. Where are they? I think you should print this or copy it. It's going to be a tough one to print. But just as a side note, where have been big earthquakes in the United States? 1755, Boston. Had some buildings damaged. New Madrid. This is one I want to talk some more about. This was a huge earthquake, 7.8 on the Richter scale. It was a big deal. Happened in 1811. And scientists, geologists believe that we are due for another big one. This would be a devastating earthquake in the United States. We'll show a video clip about that in just a little bit. And then other major ones. The San Francisco, 1989. This is, they called the World Series. It was in the middle of the World Series that this broke up. They had a 7.1. And it was very expensive. Like, highways and bridges were destroyed, etc., etc. And yeah, the Alaska, this is probably one of the biggest ones ever recorded in 1964, the Anchorage, Alaska. Tsunamis, landslides, 131 people died, etc., etc. Now, we talk about 131 people. These are the number of people who died. It seems like a small number compared to what we just saw in Haiti. Just in the last little bit, Haiti's not in the United States, I know, but they're estimating 200,000 people died in that earthquake. There's also a tsunami just a couple of years ago where they've lost about 200,000 people. So this, it was an earthquake in another place. All right, some more content. Let's talk about the New Madrid or New Madrid earthquake. All right, here we go. Let's actually first start with a quick video clip, a little history of this particular earthquake.
In southeastern Missouri, there is a small town which holds the distinction of being the namesake for one of the greatest series of earthquakes in the history of North America. The region where the Mississippi River runs past Missouri, Kentucky, Tennessee, and Arkansas has been seismically active for thousands of years. It is still active today and known as the New Madrid Fault. The New Madrid Fault is unlike most fault lines in that it does not lie at the boundary of a continental plate. Rather, it lies in the Midwest region of the United States. It was formed millions of years ago when a rift began to split the continent. For reasons unknown, this rift stopped forming. Today, the rift lies deep underground, buried by layers of sediment and rock. It also has a history of unleashing powerful earthquakes upon the Midwest. In the winter of 1811-1812, the frontier settlement of New Madrid was rocked by cataclysmic fractures within the fault system. Many of the local settlers and natives were witness to many strange and unexplainable events which caused terror, fear, and confusion. Today, the residents of New Madrid note that the region is long past due for a major earthquake, one that could become a major catastrophe that many in the Midwest have never experienced.
Wow, that earthquake could hit that region, and we would have a big issue, wouldn't we? All right, so here's some history on New Madrid. Here, or New Madrid, however you pronounce it. Here is the town of New Madrid, and there's a fault zone that lies along here, as we saw in the video, and we can see kind of the earthquakes. Each of these is a dot, represents an earthquake near New Madrid, and this would be, you know, these are where they have these. There's just a fault line, a very interesting thing, of Rift Valley that never formed, but there still are some things. Now, if we look at then in 1811, this picture I should have zoomed in on, but we'll zoom in on it here on the screen. We can see the dangers right here, and then now we have. I guess the point here is in 1811 there wasn't a lot of people who lived close to New Madrid, and now in, well, this is not exactly now, 2006 or 4 years later, there are a lot more very populated cities, and those populated cities could suffer severe damage if this earthquake were to happen. You know, of a magnitude of 7 or even 8. It would be horrid.